So before we get going on composition of functions and combining functions and adding and subtracting them and things like that, let's look at the domain a little and get some more practice. If I give you a x squared minus 7x and asked you the domain, you would simply tell me negative infinity. You'd tell me negative infinity to infinity. And why? Because you'd ask yourself two questions. The two questions are, can you divide by 0 in this? And the answer is no, because it's not a fraction. And can you take a square root in this that's negative in this one? And the answer is no, because there are no square roots in this one. For part B, you'd do the same exact thing. 3x plus 2, x squared minus 2 minus 3. You'd say, can I divide by 0? This is 2x. Well, in this case, the answer is yes, you can possibly divide by 0. Not necessarily for sure, but you have to check to find out. So what we're going to worry about is this bottom part, because if that's 0, this is no longer a number. So if we set x squared minus 2x minus 3 equal to 0, we have negative 3, negative 2, that's going to be negative 3, positive 1. So this is x minus 3, x plus 1, which means x is equal to 3 and negative 1. So if x is 3 or negative 1, we get 0 in the bottom. So we cannot have it equal to negative 1 or 3. So our domain becomes from negative infinity up until negative 1. Okay, then from negative 1 up until 3. And then from 3 to positive infinity. And so notice that what this says is go from negative infinity to negative 1. So here's negative infinity, positive infinity, here's negative 1, and here's 3 somewhere in there. So you're going to go from here all the way up to here. You're going to skip this number, you're going to go from there to there, skip that number, and then you're going to go from there to infinity. And so you can see that it leaves out all the points that make the bottom 0, and therefore that is how the domain is affected. If we go to part C, we have the square root of 3x plus 12. Well, we have two questions. Are we dividing? The answer is no. So we don't have to worry about any exclusions from that, but we are taking a square root. So if we set this square root equal to 0, square both sides, 3x plus 12 is equal to 0. And then we subtract 12. I guess we can do greater than or equal to. Let's leave it greater than or equal to, because it makes it make it greater than or equal to, because we know that it can't be the negative and we want it to switch the sign so we know the domain of this thing better. So we have 3x greater than or equal to negative 12 divided by 3. X is greater than or equal to negative 4. So then the domain, negative 4 to infinity. We know that because we use the greater than or equal to. It could technically be less than. The reason we do the greater than is because if there's a negative we're dividing by, or a negative or positive, negative we're dividing x or multiplying x by, then it will change that sign and we'll know that the domain has flipped. So I'll show you in the next one. If we do D, D is 3x plus 2, 14 minus 2x. So remember, the only part that's important really is this bottom part, and there's two things we have to worry about. We have to worry about the domain not being 0, and we have to remember that the denominator can't be 0, and it also cannot be equal to a negative, because that would make the bottom negative. Okay, so let's do what we did before. We're going to take 14 minus 2x and set it greater than 0 in this case. Not greater than or equal to 0 in this case, because if it's equal to 0, the bottom is 0, and that's undefined in this case. So that's the only reason I'm not using greater than or equal to. And the last one, it was fine because it can actually equal 0 here. Here it cannot equal 0 because it's in the denominator. So let's solve. Minus 14. Negative 2x is greater than negative 14 divided by negative 2. This is what I was talking about. X is less than 7. So what does x is less than 7 mean? That means negative infinity to 7 is our range. Or I'm sorry, our domain. Okay. And so that's why using the less than or greater than is nice, because if you get this, this is pretty easy to write in interval notation. I hope. The more practice you get, the easier it will be. So with that being said, we're going to move on. We're going to look at some compositions and adding and combining functions right now. So let's get going. F of x plus g of x. If f of x is 2x, so we're looking at these two values. So 2x plus x minus 1. If we wanted to add those, that's this part here. That's 3x minus 1. Whoop-de-doo, no big deal. If we do f of x minus g of x, 2x minus x minus 1. Notice that I put parentheses. You should do that too. This is 2x minus x plus 1, which is x plus 1. Okay, so we just got to keep track. We have f times g of x, so we have 2x times x minus 1. That's going to be 2x squared minus 2x. And f divided by g of x for g of x not equal to 0, because you can't divide by 0. So that's going to be 2x over x minus 1, and x is not equal to 1. That's the only stimulation, because if it's 1, that's divided by 0. Okay, so that's pretty straightforward, I hope. But now we're going to get into composition. So f compose g of x. So you're going to take x in. So how this works, we have f of g of x. So in f, wherever you see g, you're going to, or in f, wherever you see x, you're going to plug g into that x. So what that means is we're going to make a template with the outside. So f is 2 over x minus 1. Now, we're going to do something with that x. We are going to actually plug g into it, 3 over x. Okay. And then that is your composition. Now it says find the domain of f of g of x. So find the domain of this thing. Well, first things first, you can't plug 0 in. X is not equal to 0 right off the bat. And then x is also not equal to 3, because if you do 3 divided by 3 minus 1 is 1 minus 1, which is 0. And so I think those are your only excluded values, actually. So if you look at the notes right here, that's what's right below this. If x is not in the domain of g, it must not be in the domain of f of g. Okay, so if we plug 3 over x into that, that means it's not equal to 0. So obviously that didn't work. And then any x for which g of x is not in the domain of f must not be included. So when you plug g in, we cannot get x is 0. And so if you look, we have, the reason I said 3 doesn't work is because we have 2 over 3 over 3 minus 1, which is equal to 2 over 1 minus 1, which is 2 over 0. That's why this one happens. We can do some more. If I give you g of f of x, then let's say if I have f is equal to 2x and g is equal to 1 over 3 x squared. So g is the template. We have 1 over 3 times x squared. Well, x becomes 2x because we're plugging, wherever we see x in g, we're going to plug f. That's what this says. This just says plug it. Pretend this is your x for g and plug in f of x for that x. So this is going to be 1 over 3 times 4x squared, 1 over 12x squared. Okay. There's lots of practice, I hope, on Alex for this. You guys should be good to go, I hope. I don't think this is too difficult. I think you've done this before. I hope that you're not struggling. I hope that you're doing well. I hope that you guys are doing the student practice among other things, and you guys get these things done. Thank you guys.